The video, use of a dictionary to understand and read any difficult text in English, provides a structured methodology for breaking down complex language. While the example used in the video is Aristotle's Poetics, the core principles are highly effective for mastering technical subjects like maths and science. Here is how the method shown in the video can be applied to technical learning. 1. Identifying and defining technical terminology. In technical subjects, difficult words are often specific jargon or variables. The video suggests identifying and defining these terms immediately. 141. In science, when encountering a term like mitochondria or entropy, looking up the definition and simplifying it, just as the video does for purgation, 049, helps remove the initial barrier to understanding. In maths, defining the properties of a hypotenuse or polynomial before solving a problem ensures you aren't stuck on the language rather than the logic. 2. Simplifying and paraphrasing complex laws. The video demonstrates how to rewrite a dense paragraph into a simpler version. 104. This is a powerful tool for scientific laws or mathematical theorems. Application. You can take a complex scientific law, like Newton's third law, and paraphrase it in your own words. The video notes that this aids in better retention and memory recall. 214. 3. Focusing on key concepts. The core method. The video emphasizes focusing on core ideas, rather than getting lost in the density of the text. 203. In technical subjects, this means identifying the first principles. Instead of memorizing every formula, you use the video's method to understand the underlying concept, the key concept that makes those formulas work. 430. 4. Handling technical or academic writing. The video explicitly mentions that this method is applicable to technical or academic writing, including research papers and specialized texts. 406. Comprehension. By breaking down the complex language of a lab report or a mathematical proof, you can grasp the logic without being intimidated by the high-level vocabulary. 341. Summary of benefits for STEM students. Improved comprehension. Breaking down complex language helps you grasp difficult scientific ideas. 214. Universal applicability. The technique works regardless of the subject matter, whether it's literature or physics. 319. Enhanced analysis. Understanding the basic definitions allows for a deeper analysis of complex problems. 229. By applying this slow and careful reading approach. 243. Students can bridge the gap between reading a textbook and actually understanding the technical material. Watch the full video here. Link to YouTube. The methodology shared by Sundesh SS for reading science and technical textbooks focuses on bridging the gap between mathematical formulas and linguistic definitions. Below is a comparison of his approach using illustrative examples from his videos. Method overview. Sundash SS argues that to truly comprehend a science or maths textbook, one must understand the dictionary or linguistic meaning of the terms before or alongside applying the mathematical formulas. 1. Illustrative example. Statistics, mean and standard deviation. In his video on statistics, 013, he demonstrates this by breaking down a formula into understandable parts. The formula, sigma equals sqrt, frac, sum x squared, n, frac, sum x, n, squared, 106. The linguistic step. Before calculating, he defines three core terms using dictionary definitions. Raw data, data collected directly from a source, like a lab experiment, that hasn't been processed, 202. Mean, the average or most common value in a set, 243. Standard deviation, the measure of variation expected around the mean, 316. The verification. After calculating the standard deviation, e.g., 1.63 for the numbers 2, 4, and 6, he shows that the result physically matches the definition, demonstrating that the data varies between the extreme values of 2 and 6 around the mean of 4, 534. 2. Illustrative example. Physics, measuring instruments. He applies the same logic to a physics context involving needle deflections in a measuring instrument, 629. The problem. Deflections recorded at 10, 6, 20, and 26. The comprehension. Instead of just finding the average, he uses the standard deviation to understand the variation of the random variable about its mean. The result. He calculates the mean, 18, and standard deviation, approximately 8, then shows that the extreme values, 10 and 26, perfectly fit the mathematical definition of how much the needle's movement varies from the average, 828. Key comparison, general English versus science comprehension. Feature, general reading, e.g., Aristotle, science reading, e.g., statistics, physics, primary goal. To understand difficult text or philosophical concepts, 009. To understand how formulas relate to physical reality, 851. Vocabulary. Defines abstract terms like purgation or pity, 049. Defines technical terms like raw data or random variable, 131. Output. Rewriting the text into a simpler paragraph for clarity, 104. Calculating values and verifying they match the definition, 609. Focus. Paraphrasing and retention of ideas, 214. Accuracy of application and conceptual grounding, 430. References from the video, use of a dictionary to understand and read any difficult text in English. Summary of the Sundash SS approach. The channel advocates for a three-step loop. Identify the technical terms. Define them using a dictionary or Google for conceptual clarity. Apply the math, science, and verify that the result aligns with the linguistic definition. Relevant videos for further study. Illustrative examples for a method of reading comprehension for science textbooks. Discussion with Meta AI of my method for science textbooks.